Welcome to the lecture on data visualization. In the previous lecture, we have been looking about how to create basic plots using Matplotlib library. The basic plots include scatter plot, histogram and bar plot. In that lecture, we have seen how to create these plots, and we have also seen what Matplotlib library is about and how to interpret each of these plots. And in this lecture, we are going to see how to create basic plots using Seaborn library. And the basic plots includes scatter plot, histogram, bar plot, box and whiskers plot and pairwise plots. We will see in detail about the creation of these plots and how to interpret them. So, first let us see what Seaborn library is about. Seaborn library is a Python data visualization library which was built on top of Matplotlib library that provides a high level interface for drawing attractive and informative statistical graphs. So, using Seaborn library, we are going to first see how to create the scatter plot. So, before creating the scatter plots, we need to import the basic libraries that are needed for visualization. So, let us import the necessary libraries. We are importing the pandas with an alias PD because to do the visualization, we need to have a data frame. Here, we are going to create plots using a data frame. Since we are going to deal with data frames, we are importing the pandas library. If we wanted to do some numerical operations on it, then we need the NumPy library. So, let us import the NumPy as NP as well. Then we can import the libraries that are needed for visualization. Here, even though we are going to create plots using the Seaborn library, we are also importing the PyPlot from Matplotlib library with the alias PLT, because as we know that Seaborn library has been built on top of the Matplotlib library, we will be using some of the functionalities that are from the Matplotlib library. In that case, we would be needing that library. So, let us import Matplotlib as well. Followed by that, we can import the Seaborn library as SNS. Here, SNS will be the alias for the Seaborn library, and Matplotlib and Seaborn will be used for data visualization. So, now we have imported the necessary libraries into Spider. Now, it is time to import the data that will be used for the visualization, because as we know, we do visualization to understand the data even more better. So, on that note, we are going to import a data into Spider to understand the data visually. So, we are going to import the Toyota data which we have already worked on. Since it is of CSV format, I have used pd.read_csv, and while reading itself, I have considered all the missing values as the default NaN values, and I have saved it to an object called cars_data. Now, cars_data is a data frame. When we looked at the size of the data frame through the variable explorer, you can see that it has 1436 observations with 10 columns, and now we are very familiar with what Toyota data is about. They are just the details of the cars. So, since our objective is to understand the data pictorially or visually, we need to consider only the rows wherever the records are filled, because we will not be able to interpret anything from the question marks or from the NaN values. In this case, our objective is to basically understand the data and understand the relationship that exists between each of the variables. In that case, we wanted to remove missing values so that we will focus on understanding the data which have complete informations from the data frame. So, on that note, we can just remove all the missing values from the data frame and then proceed with the visualization. So, let us remove the missing values from the data frame by using the command drop NA, and inside the function you can just say axis is equal to 0. So, that all the rows will be removed wherever there are NaN values, and if you use in place is equal to true, you are making all the modifications in the data frame that is being used here. Otherwise, you have to reassign it to a new data frame called cars_data2, or you can update it in the existing data frame itself. So, here I have updated while I am using the function itself by using in place is equal to true. And after dropping all the missing values, if you look at the size of the data frame, it is turned out to be 1096 observations with 10 columns. On the whole, we have removed around 340 observations from the data frame, and we are going to proceed with the analysis only with the 1096 observations with 10 columns. So, now let us see how to create the scatter plot. So, here we are going to create a scatter plot of price versus age, and that will be built using the default arguments. So, if you see the first line I have given as SNS dot set, that means that we are giving a theme to the background of the plot. The theme is being dark grid, that means that you will have a dark shade as a background of your plot, and you will as well have a grid. So, you can basically set themes to your background, and dark grid is a preset Seaborn theme. You can as well set themes that are available from the Seaborn package, and you can set that under the style argument. And even by default, if you use SNS.set, it will give you a dark grid theme. So, in order to do a scatter plot, the function to be used from the Seaborn library is regplot. Regplot stands for regression plot, and inside the function you have to specify the variables for x axis and the y axis. Since it is going to be the scatter plot of price versus age, we need to give age under the x axis and price under the y axis. We are going to check how price varies with respect to the age of the cars. So, here if you see, I have accessed the age variable from the data frame cars underscore data. Similarly, I have accessed the price variable from the cars underscore data. So, this would be the output that you will be getting by setting the style as dark grid and by giving x as age and y as price. And if you see here, as the age increases, the price decreases, and the age that we see here is not in terms of years, but it is in terms of months. So, 70 represents the car's age is around 5.8 years, and 80 represents the car's age is around 6.6 years. So, in that case, most of the cars or the price is really low whenever the car's age is beyond 5 years, and the price is really high for the new aged car, because the car has travelled a lot, there could be more damage to it, and since it is not new, the price is also coming down. So, it is very obvious from the logic perspective as well as from the data perspective, as age increases, the price automatically decreases. And if you also see, there is a regression line which is plotted over the scatter points. That is because by default fit underscore regression is equal to true in regplot function. What it does mean, it basically estimates the coefficient of x and then plots a regression line over the points. That is why the function is named as regression plot. And if you do not want to consider this regression fit line into your scatter plot, if you just want the scatter plot of any two variables, you can also do that. Like here we are going to do a scatter plot of prices age without the regression fit line. That is very easy. You can retain the same command as the previous slide, but you just need to add another parameter called fit underscore regression, and you can just set them to false, because as I mentioned earlier, by default it is true. That is why you got a regression line over the scatter points. But if you set it as false, you will not be getting the regression line, rather you will just get the scatter plot of price versus age. So, and here if you see the plot, age is called as the label to the x axis and price is called as the label to the y axis. Here we have not specified any labels to x and y axis, it is already being shown here. That is how, because it takes the labels from the variable name that we have already given here, and the values 0, 10, 20, 30 are the values from the variable age, and from the plotting context these are called x tick labels, and 5000, 10,000 and so on are called as y tick labels, since that is on the y axis. The boxes are called as grids, and the points, the scatter points are called as markers. Here we have a solid round points. So, now we are going to see how to create a scatter plot of price versus age by customizing the appearance of the markers. Appearance of the markers in the sense, you can change the shape of your markers to differentiate between the categories, but here I have just taken only the scatter plot of price versus age. So, I am going to change all the markers into a different shape. So, in that case I can do that using the argument called marker, and inside the marker argument you can specify the type of marker you wanted to have it in your scatter plot. Here since I have given the asterisks, all the scatter points will be marked as stars. This will be very useful whenever you want to differentiate the points with respect to different categories that are available under a variable. Other than that, all the codes remains the same. I have just added marker is equal to star, that should be given under the single or double quote. So, in this example, we are going to create a scatter plot of prices as H by fuel type. By fuel type, in the sense, we are going to add one more variable into the scatter plot, that is the variable fuel type. Why are we going to add that? Because it is of interest to check the relationship between price with age by adding another variable fuel type, like how price varies when the age increases with respect to different fuel types of the car. So, that can be added by using the parameter called hue and including the another variable to show the fuel type categories with different colors. Here we are going to add fuel type under the argument or parameter called hue, and we are going to represent the fuel type with respect to different colors. So, here we are going to do that by using the command called LMPlot, that is from the Seaborn library. LMPlot is a function which combines regression plot and phased grid. It is very useful whenever you want to plot a scatter plot by doing conditional subsets of data or by including another variable into the picture. In that case, LMPlot will be very useful, and here the x axis is age variable and the y axis is the price variable, and the data from which we are going to access is the cars underscore data, and I have also set false to fit underscore reg, so that we do not get a regression fit over the scatter points. And here I am adding one more variable into the scatter plot using the hue parameter, and since we are going to add one more variable, points are going to be differentiated using colors based on the fuel type of the car. In that case, we need to know which color represents what category. In that case, I need to have legends as well. So, I have set legends as true, and you can also set color palettes using the different color palettes that are available in the Seaborn library. One of it is called set1. So, I have just used set1 as the color palette to color the data points based on the fuel type. So, this is what the input is about. Let us see what is the output that we are getting. So, this is a scatter plot of price versus age by fuel type. It is the same scatter plot, but here we have just differentiated the data points using the categories that are available under the fuel type, but we have just differentiated the data points based on the fuel type categories. So, the red represents diesel and the blue represents petrol and the greens are CNG. So, if you see here, there are more data points or there are more cars that are of petrol fuel type, and the price is really higher for the cars which has diesel fuel type, and the price is comparatively lower for the cars which have CNG fuel type. And you can also check the relationship between price and age, as we know that whenever the car's age is high, the price is very low. Whenever the car's age is low, the price will be high. Similarly, you can also custom the appearance of the markers using transparency, shape and size. Like how we differentiated the points using colors here, different levels of transparency to the points to represent the categories. You can also do the same thing by giving different shapes and by giving different sizes for data points. So, this will help you include more variables into a single plot, or you will be able to understand the data quickly rather by looking at the numbers. So, next we are going to look at a plot called histogram. So, we are going to plot a histogram with default kernel density estimate, because using the Seaborn library by default it gives you a histogram with the kernel density estimate. So, the command that needs to be used is distplot, that is the representative of distribution plot. Since that is from the Seaborn library, I have used sns.distplot, and the input should be any numerical variable or any continuous variable, because histogram can be plotted to check the frequency distribution of any continuous variable. In that case, age is one of the continuous variables from the data frame. Here we are interested in looking at the frequency distribution of age, how the values are distributed under the age variable. In that case, you can use or you can access the age variable from the data frame cars underscore data. So, this is being the representative of the x axis. And as you know, by default it gives you the kernel density estimate, it gives you a curve over the bars which is the representation of the distribution of the variable age, and on the y axis you have the kernel density estimate. But if you are interested is to get the frequency distribution in terms of counts or numbers, then you can also get rid of the kernel density estimate and then have the counts on your y axis. Let us see how to get that. So, here we are going to plot histogram without the kernel density estimate. You can do that by setting KDE is equal to false. So, if you give that, the output would be similar to this. On the y axis, it is just the representation of frequencies or the counts. On the x axis, you have the range of values from the age variable, and you have too many intervals here. It is very difficult to interpret from this plot. The range is about 75 to 80, where the car's age is more than 6 years, the count is really high, and there are very few cars which are new. That is what we can interpret, because there are two extremes here, one is really high and one is really low. So, in that case you can also have a control on how many number of bins you want to have on the plot. So, that by having the control on the bins, you will be able to quickly interpret from the distribution of your age variable. Let us see how to fix the number of bins. So, here we are going to plot the histogram with fixed number of bins. So, retain the same codes as in the previous slide. You can just add bins is equal to 5. So, that you will have only 5 bins in your histogram. Bins are nothing but the range or the intervals. So, from this plot, by having the number of bins as 5, it is very clear that the frequency is really high for the bin value 70 to 80. That means that wherever the car's age is above 5 years, the frequency is high, because most of the car's detail is about the cars whose age is about 70 to 80 months, but you have only very few cars which are very new in our data frame. That is why the frequency is very low in the range between 0 to 50 months. So, next we are going to look at the bar plot. So, bar plot is basically to check the frequency distribution of any categorical variable. Here fuel type is one of the categorical variable in our data frame. So, let us look at the frequency distribution of the fuel type of the cars. So, to create a bar plot, count plot is the function that needs to be used. Under the function, you just need to give the variable of interest, that is fuel type, and you can also specify from which data frame that you are accessing it from. It is cars underscore data. So, it is straightforward, you will get the output. You are getting the fuel type on your x axis and the count on your y axis, and the bars are the representative for the counts with respect to each fuel type. So, it is very evident from the plot that most of the cars have the fuel type as petrol, and there are very few cars whose fuel type are diesel or CNG. So, now we have seen how to create the bar plot. So, here we are going to see how to create group bar plot. We are going to create the group bar plot of fuel type and automatic. We mean by group bar plot. So, here we are going to have the bar plot of fuel type by adding another variable as automatic. So, we are going to look at the frequency distribution of the fuel type of the car along with the interpretation whether the car's gearbox is of automatic or manual. So, let us see how to do that. We can use the same function as bar plot, that is count plot, and you can specify the fuel type under the argument x, and you can also specify the data frame, so that it knows from which it should access the fuel type from. And by adding hue is equal to automatic, we are including one more variable into the bar plot, so that we are checking the relationship between fuel type and automatic. So, let us see what would be the output. So, here is the output. On the x axis you have the fuel type, you have different fuel types like diesel, petrol and CNG, and on the y axis you have the count. If you see the legend here, it has two values, zeros and ones, and the zeros are the representative of manual gearbox and the ones are the representative of automatic gearbox. So, if you see here, there are only automatic gearbox types whose fuel type is of petrol, and there are no cars available with automatic gearbox when the fuel types are diesel or CNG. If you recall, this is just the visual representation of the crosstab output that we have seen earlier in the lectures. So, we have used the crosstab function to arrive at the relationship between the automatic and the fuel type, where we have seen that in terms of numbers and we have tried to interpret that, but here using visualization we are going to interpret the same thing, but visually. So, next we are going to look at box and whiskers plot. We are going to look at this box and whiskers plot for numerical variable. For if you have a numerical variable in your data frame and if you want to interpret more from the variable, then you can go for box plot, because The box plot will give you the visual representation of the 5 number summary includes mean, median. The 5 number summary includes minimum, maximum and the 3 quantiles. Those are first quantile, second quantile and third quantile. So, let us see what the quantiles are and what the minimum and maximum values are. So, how do we do that? We can create a box plot using the command box plot, that is from the Seaborn library, and since we are interested in getting 5 number summary of the price variable, I have accessed the price variable from cars underscore data and I have given that under the argument called y. So, that the y will be the representation of price, but if you give it under x, the x will be the representation of price. So, now let us see how the output will look like. So, as I have mentioned, since we have given price under the argument y, we are getting the price value on the x axis. So, now let us try to interpret the box plot. It is called as box and whiskers plot because it has box as well as the whiskers to it. The horizontal lines are called as the whiskers. Now, let us try to interpret this. This horizontal line is called as the lower whisker or also the representation of the minimum value, which is excluding the outliers. If you have outliers in your data which are nothing but the extreme values, then it excludes that values and then gives you the picture of what is the minimum value of the price. The minimum value of the price of the car is about 5,000 euros and the upper whiskers, which represents the maximum value, that is excluding the outliers. So, the maximum value of the cars is around 16 to 17,000 by excluding the outlier or the extreme values, and these are called lower whisker and the upper whisker. The lowest horizontal line of the box represents the first quantile, that is 25% of the car's price is less than 8,000, and the middle line represents the second quantile, which is nothing but the median. That means that 50% of the data is less than 10,000 euros, and the upper horizontal line is nothing but third quantile, that is Q3, which represents that 75% of the price of the car is less than around 12,000 euros. This is called Q1, Q2 and Q3, and whatever the points that are lying above the whiskers are called as outliers, and you can also have the values below the whiskers as well. If you have points above the upper whisker, then you can say that these are outliers or the extreme values, where the values are really more than the 1.5 times of your Q3. This is what the Q3 value is about. The Q3 is around 12,000. So, these values are 1.5 times of Q3, that is why it is called as extreme values. It is not in between the range of the price, that is why it is called as the extreme values. Similarly, you can ask what happens when you have some values above the lower whiskers. In that case, those are also called as outliers or extreme values, because those values will be less than the 1.5 times of Q1. So, using box plot, you will be able to visually look at the distribution of the price variable and what would be the median value and what are the quantile values of the price. And using the box plot, the main key point to the box plot is you will be easily able to identify the outliers of any numerical variable. So, this is how we create a box plot and this is how we interpret the box plot as well. So, now we are going to look at the box and whiskers plot for numerical versus categorical variable, because box and whiskers plot is very useful when you want to check the relationship between one numerical and one categorical variable, like how the price varies with respect to the another variable. Because in the previous example, we have just looked at the distribution and how do we detect the outliers using the box plot. Here we are going to check the relationship between two variables. In that case, you can use box plot. You can use box plot when you have one numerical and one categorical variable. Here we are going to look at the price of the cars for various fuel types of the cars. So, you can use the same command as in the previous slide, that is box plot, and under the x argument I have given fuel type and under the y argument I have given the variable as price. So, you have fuel type on your x axis and you have price on your y axis, and by looking at the plot, it is very evident that the price varies with respect to different fuel types of the cars. And as we know that the middle line is the representation of the median, if you look at the middle lines of the different fuel types of the cars, the median price of the car is really high when the fuel type of the car is petrol, and the median value is really low when the fuel type is of either diesel or CNG. It is very evident that on an average the petrol fuel type has the highest price among the cars from the data set that we have. And you can also see the maximum value of the maximum price of the car is for the diesel fuel type, and the minimum value of the car is also for the diesel fuel type. So, these are the interpretation that you can make here, and you can see there are some extreme values that are above the upper whiskers of the diesel and petrol fuel type, and those are called as the extreme values, because very few observations are there and those are above the 1.5 times of your third quantile, that is 12,500 euros. So, now we have checked the relationship between fuel type and the price. So, now we are going to look at the grouped box and Whiskers plot. Here we are going to look at the group box and Whiskers plot of price as a fuel type by including one more variable called automatic. So, let us see how to do that. The codes remains the same. Whenever you want to have a grouped box plot, you just need to add that variable including the argument called hue, and I have added automatic under hue. So, we will have a group box and Whiskers plot. Let us see what the output is about. So, here you have the same box plot as the previous slide, but you have another boxes which is corresponding to the different fuel types, and you have another boxes which are the representation of the automatic variable. Here if you see, the automatic variable is being included here, and the zeros are the representative of manual gearbox and the ones are the representative of automatic gearbox, and those are represented by blue and green in color respectively. So, here whenever the car's fuel type is petrol and the gearbox type is also automatic, there are no cars that are available for the automatic gearbox when the fuel type is of either diesel or CNG. That is very evident from any of the plots that we have seen in the previous slides as well. Till now we have been looking at having only one plot in a window. We can also have multiple plots in a window. Here we are going to look at the box and Whiskers plot and the histogram on the single window. So, let us plot box, Whiskers plot and histogram on the same window. So, in order to do that, we have to first split the windows into two parts. What do we mean by splitting the windows into two parts? This is what we mean. So, this is a single window. I have just splitted the window into two, so that I can plot two plots in the same window, and it will be easier for me to interpret from the two plots instead of creating different plots for the same variable. I can as well do that in the same window itself. So, here if you see, there is only small space for the upper part and there is a large space for the lower part. That is how, because I have set the aspect ratio with just because I have set the aspect ratio accordingly. Let us see how to split the window with giving let us see how to split the window, plotting window, and we will also see how to customize the aspect ratio. So, subplots is the function that is used to create the subplots, and by giving 2 you mean that you need to have 2 rows. So, you want to split your window into 2 parts in row wise, and by giving specification of grids using grid spec underscore kw, you can set the ratios of your height. I have given 0.15 and 0.85. So, that there is a larger space for the second window and there is a less space for the first window. I have just splitted my window into 2 and given the aspect ratio, and I have saved that output to two variables called f and axis box plot and axis for histogram, because these are going to be same for both the box plot and the histogram. Combinedly I have saved it to 2 objects, and I have also saved it to a figure. So, Ax underscore box represents the axis for box plot and Ax underscore hist represents the axis for the histogram. So, let us now we can add or create 2 plots. So, the codes remains the same, because for creating the box plot you have to use the box plot and the variable of interest is price, and using the axis Ax underscore box. And we have also created the histogram using the dist plot function, where we have specified the variable as price and where we have also specified what is the axis for that, that is using the same axis, that is ax underscore hist, and we wanted just the histogram with not the kernel density estimate. So, that is why we have set kd is equal to false. So, let us see how the output will look like. So, this is the output for the first command using the box plot. You are getting the box plot for the variable price as well as you are getting the histogram for the variable price. So, here this is a histogram of price as well as the box plot. So, you will be able to look at the frequency distribution of any continuous variable as well as the file number, as well as you will be able to look at the visual representation of file number summary of it. If you want to look how the outliers are present in a variable and what is the minimum and maximum value of a variable. So, all these information can be get using a single plot when you create plots using subplots. So, now we will see how to create pairwise plots. Pairwise plots are used to plot pairwise relationships in the data, and basically it creates scatter plots for joint relationships and histograms for univariate relationships. We will understand what do we mean by joint relationships and univariate relationship when we look at the output of it. So, to create the pairwise plot, the command that is used is pair plot, that is also from the Seaborn library, and you can also specify the data frame, because on the whole we are going to look at the relationship between all the variables, considering all the variables, and the kind of plot that we are going to plot for any numerical variable is scatter, and we are going to color the data points using another variable called fuel type. So, now let us look at the output of the plot. So, this would be the output of your pairwise plot. You basically have the all possible relationship using all the variables. So, the first plot is like the distribution of the price, because on the x axis you have price and on the y axis also you have the price variable. So, this is called as joint relationship. Whenever you have same variable on both x and y axis, then you call it as joint relationship. In that case, you will just have the histogram of it, like to indicate the frequency distribution of the variable price. But here the next plot, if you see, the y axis is price, and if you look at the x axis it is age. So, this is actually, so when you move from left to right, whatever you have in your x axis is the representative of the x axis, and whatever you have it in your y axis is the y axis variable. So, this is the scatter plot of prices as age. It is very evident that as the age increases, the price decreases, and all the colors are the representative of various fuel types of the cars. So, similarly, you will be able to interpret it for the other variables relationship, and if you see, all the diagonal boxes are histograms, because all the diagonals values represents, all the diagonal boxes represent the univariate distribution, because this is just the distribution of the variable age, and this is just the distribution of the variable kilometer, and the distribution of the variable is HP is being represented here. So, the pairwise plot is used to get the plots for all possible combination of variables, and you will be able to look at in terms of scatter plot and histogram. This would give you an easier way to understand the relationship that exists between different pairs of variables. You can also see there is a legend which is shown here for the fuel type, like how the markers have been colored. So, now we have come to the end of the session. Let us summarize whatever we have learned till here. So, we have learned how to create the basic plots using the Seaborn library. The first thing that we have seen is how to create scatter plot, and then we have seen how to create histogram using the Seaborn library, and we have also looked at how to create simple bar plot, and then we have seen how to create grouped bar plot. Followed by that, we have seen how to create box and whiskers plot, and also we have seen how to create group box and whiskers plot. At last, we have seen how to create the pairwise plot from the Seaborn library, which was very useful to look at the relationship of all the variables in a single window. So, thank you.